Now let me turn things over to our presenter. David, the floor is yours.
Thanks very much, Nancy. So we'll go through our session to learn how to read a data sheet, which is, of course, one of the very central things to get you to use our parts and to figure out what they're going to be able to do for you. So we'll get right started. What we're going to cover are the purposes, what's a data sheet for, what are you looking for today, and how do you find it, how you go about doing a product selection, specifications, how we specify them, and their conditions, a discussion of the absolute maximum ratings, thermal analysis, the theory of operation applications, packages, and other ways to find out information you're looking for. And specifically, we're going to tell you what's not in a data sheet and where you can find it. So what are the purposes of the data sheet? First of all, of course, describes the product and it lets you figure out, is this going to work for me? It's an owner's manual. This is how you go about using the product, all of the functions. We make sure that if a given function is built into a product, we tell you how to use that function. Otherwise, we wouldn't need to do it. Sometimes a complex product, such as a DSP and some of our more recent products like transceivers, have a separate manual for programming the product, and those manuals can run to 1,000 pages now. So that there are supplemental parts to the data sheet in some cases. You can go through it and get some application ideas like, look, yeah, I could do it. I could use it that way, and it might give you some new ideas as well. Another key thing is that this is a warranty document. What do we guarantee? What can you do that might void the warranty of the product? In the few cases, today it's like a few per million, what might let you send the product back if you think it's defective. So let's take a look at where you're going today. The idea generator, you can look through some of the applications for how you might want to build some new function or improve one you're already doing. Product selection, there are myriad products available that can do many of these functions, and which is the exact right one for my needs. And then in the owner's manual, how do I get it to work? And you may also find, it will also tell you where to find other things that will be needed to get your application to get going. So let's start out with choosing a product, and what is the progression of choosing a product. And today, and it's been for quite some time now, you go to our website. At one time we had huge paper catalogs that you would use, but now you go to our website, walk down through our product types, which is in our the hierarchy under products, and go to an area of a given product type. In this case, we're looking at high-speed amplifiers, high-speed low-noise amplifiers, and you get a selection table. That selection table can be sorted by a specification, or in fact, you can enter put it into a parametric search mode, and then you can figure out which one you want out of those. That looks likely, and then you would click on one of those. It will go to the product page for that product. Then you get to see some more features and specifications and a functional block diagram, and then you can look at the block diagram and say, yeah, that's about what I need. It does this, it does that. Or you'd say, nah, it's missing this function. I've got to try another one. So then you can go back to the selection table, or in some cases you can enter a search and find what you're looking for. So let's say you find one that you like, and then you would go to the data sheet. So you can look at the product page, get a pretty good idea what the product can do, first level specs, and then you go to the data sheet, and that has the complete specifications, block diagram, in some cases an even more involved block diagram, detailed description, all the applications, and then you can look through that and see whether the product is going to fit. And you know, sometimes there will be a detail, such as, say, the nature of the interface, that's not going to work out. But it would be a rare case that you would not be able to find something that's going to fit your needs. So now let's dive into the details of what you're going to find on the data sheet. First of all, we have the specifications, and those are in about the 4th or 5th page of the data sheet and go on for 4 or 5 pages. And this is the details of the performance of the product. There's a lot more specs here than what you'll see in the primary features, and it's what we guarantee, and it's essentially everything that has to do with accuracy, timing, speed, you know, the whole works. And we try to specify it as completely as possible. For example, you see in this case the voltage range in both unipolar and bipolar. In some specifications, you're going to see that we show a minimum and a maximum, and in some other cases, maybe just a typical, or maybe all three. And it will depend. You know, not everything has a minimum and maximum. It's we would deem that if you have a good idea where that product performs, that it's going to get the job done for you. Then, if you need to, we typically will have a set of definitions, particularly if it's a new type of product, that precisely define how we interpret specifications. In most cases, this is going to be pretty much an industry norm, but there will be an occasional situation where you find that we might define a specification somewhat differently from the way someone else in the industry will define that spec, and it may or may not make a difference. And sometimes the fine print on that will make a difference. That oh, that means that you know, this part of it is different. And in some cases, that may explain why one person's specification looks better or worse than some other company's specification. It could be in the definition. So then we have a situation such that the top of the data sheet is like the family name of the product, and in most cases there will then be models of that product, which are the actual things that you buy, and those models may have different temperature ranges. In some cases they'll be in different packages. Some cases they'll have different specifications. And then you would want to look at the data sheet to see the details of what those differences are. In some of the cases there will then be a very complete, a much more complete set of tables where we separate that out by the different model types. So then we, within the specifications, we have conditions. There are general conditions at the top of the spec page, and that would be the power supplies that were used during the testing, the operating temperature, normally 25°C, the signal range of input, and then many other conditions, possibly reference loading and so on, that would define how we did the testing. And we'll get into another aspect of that later. So this is fairly simple for op amps in that we've got a power supply, maybe a load resistor, the gain or feedback network. So it's pretty simple. For other products, it can get to be more complex in terms of the speed it's operating at, the clock, and so on. But you want to look at the general conditions to make sure it's how you're going to operate the product. So then for certain specifications, we will add more conditions. And particularly this is the case for dynamic specifications. We need to specify what frequency is being used or the nature of the waveform that's being applied. And also, like in the case here of open loop gain or many other specifications, you may want to know how it performs over different signal ranges or different loading conditions. And then the spec can be different, and we will show that. And some of the specs where there is a considerable difference under different conditions, we'll make sure to show that because we know that different applications can call for that. So then sometimes you get into power supplies, then the conditions can be very specific, and it can be very important to your design, particularly today when there is so much emphasis on building systems that are very low power, so that you really care about how much power is being used in different operating modes. So we go into a fair amount of detail on that, and we can see that in this case the total supply current being used. Now this is a pretty high power part, but it's in fact a power product, and it depends on a lot of different situations as to exactly how much power is being used. So you'll want to look at that. Some products have shutdown modes, and then the power supply usage is different. And we try to provide all of the different conditions so that you can set up your product for the lowest power operation. So then we get into details. The fine print. Very often you'll see next to a specification a superscript number, and then that will refer to a note at the bottom of the page, or perhaps in some cases way at the end of the specifications, and it will say, in this case, there's a slightly different condition, and normally it's too long to put into the conditions section, or it may be a clarification of what goes on. So you want to make sure you look at those notes whenever those come up. So now we'll discuss the minimum, maximum, and typical, which has been an area of discussion for a very long time in this business. All specifications, as we say here, have a distribution of values. They're not all exactly 1 volt or 50 kilohertz or whatever it is. There's, we make tens of thousands of these at a time, and they're not all quite exactly the same, as much as we try to make it that way. If the specification says typical, it is not tested often. What we do at the start is that we will do 3 production runs, 3 separate wafer runs, so we can get a distribution of product, assemble parts out of that, and then the test and applications engineering people will test everything that we say that there is a typical for through a fair number of parts, usually a couple of hundred, and see where those numbers lie. And then some will be a little above, some below, and as we say, sometimes the distributions on this are a little looser than others, but for the most part, we'll put in the average of what all of those couple hundred parts are that we test, and then those are screened by QA, and then on something like a yearly basis, depending on the volume of the product, we'll do rescreen just to make sure that we haven't had any movement in the process technology. Now, for the most part, when it says minimum or maximum, we do test 100% at final test, but not always. And particularly when we say that the spec is so and so much over temperature, that for the most part in our industry is not tested 100%. And there is extensive characterization of the product over temperature to be sure that that we make those limits. And they are, I mean, we find where the numbers are, and then we actually give a little more room to make sure that we're well within that over temperature. And again, this is the testing and specs are driven by statistics, and we know that you know, there will be outliers on this sort of thing, but we find that the min-max limits are at least 4 standard deviations away from the nominal. And again, as we say, the QA also does acceptance testing of production lots, and our outgoing QA is in the few parts per million of devices that don't meet spec, and this is of all specs for the product. So very, very few products would be even a little bit out of spec. So then, to expand on this further, we have typical performance curves, or TPCs. And the typical performance curves show the performance of the product over its full operating range. And it would show the operating range that you would be interested in. Again, we develop this by characterizing a large number of parts. Some of these things are pretty difficult for you to test, but it does show how the product works. It's an important part of your product selection, because where we specify the part in terms of the conditions I spoke of might not be exactly where you want to use the product. So you can look at the typical performance chart and say, here's where I'm going to use it. Okay, that number looks good. And then you know, we'll try to find, and there will be, you know, on some products there are pages and pages of these typical performance charts, so that in most cases you're going to be able to find your operating range. This would be a few examples of these. On the TPC4, that's the noise performance of the product, both current noise and voltage noise over a wide frequency range, and we show in the upper right of that the conditions under which we did the testing, and then we also and then you can see the frequency sweep of the product and a couple of conditions in the upper right layout. We then also reproduce a scope photograph of the performance of the product, particularly things like settling time, maybe the peak-to-peak noise, some of those types of things. We will put onto what you know, our drawings of what the scope photo looked like, so you can get an idea of the performance. But like I say, there are dozens of pages of these things, so you'll be able to find what you're looking for. Now the next section, which is very important, is the absolute maximum ratings. And this section on our data sheets usually appears after the specifications. And this will describe the limits that if the product goes beyond those, it will result in device damage. Maximum voltages between the pins, maximum power supplies, the amount of current that can be tolerated in and out of pins, maximum temperatures for usage and storage, and then the soldering conditions. So, you know, all of these things matter. So, for the most part, if you exceed in operation or testing those limits, then that product is going to be suspect, that particular unit. And so the question is, what do you do? And so let's say something inadvertent happens, and the product has undergone a condition where it exceeds absolute MAC rating of one or another of those. But then you shut off the system, turn it back on, and it seems to work. You go, now what do I do? Well, it's quite likely that something has been compromised in the product, and it would be wise for you to change it out, because if you're making tests of your system, you could be getting erroneous results. Particularly if this is an evaluation system for a customer, don't send that to a customer, because it could fail. It might still be working, and in some cases, they could work for a very long time. But in most cases, they will not work, and they're likely to fail at the worst possible moment. So you certainly do not want to operate at near the max ratings of the power supplies, because what can happen is that you can get a spike on the power supply because of certain loading, or a spike to the input of that power supply that propagates, and even a brief exposure to excess power supply can cause a part to fail, or to induce the possibility of future failure. And so you want to be careful not to get too close, because it's even, microseconds can cause an oxide failure. So some things that are a little difficult to see, we'd have sensitive input stages where you need to be careful about how much current can flow into them. If you, even though we'll have what we show here are back-to-back diodes that will keep the input stage from getting an over voltage, you can still have a situation such that those diodes will conduct current, and you could get too much current going through, which could lead to a fuse condition in the input wiring, and you need to be careful of that. So you may want to put additional protection outside the part, and on most products we show how to do that. Newer and newer designs of these products, we're building some of that stuff into the front end of the product, but you need to check very carefully, particularly if the product is going to be connected to external inputs. Now, thermal considerations. Heat is the enemy of all electronics. We know that. And our chips have a maximum operating chip temperature, which means the junction of the product. It's typically somewhere in the range of 125 to 150 C. If you exceed this temperature, you can cause high leakage currents, possible permanent damage, may not show up right away. You also get an electromigration activity that goes on, which will set up incipient damage and will shorten the lifetime of the product. But the junction temperature is the ambient temperature plus the temperature rise from self-heating, which is generated by the product being in use. So it's determined by the power dissipated and the thermal resistance of the product. So for an example, if the chip is using 5 milliamps from a 5-volt supply, that's 0.025 watts. And if it has what's known as the thermal resistance theta junction to ambient of 115 degrees C per watt, that's a small package. The temperature rise in this situation is only 2.88 degrees, so that's not going to hurt anything. But if you have products that run at higher power, or you run at higher supplies, and let's say you've got a 30-volt design at 10 milliamps, that's 0.3 of a watt, and now you've got almost a 35 degree C rise, and that's going to be, you can get up to where you're too hot to touch. And that's, that's one thing, but it also is going to compromise the product. And often, you need to do that, but because that's the way your system works. So we have then temperature derating curves, where it says that if you want to use the product at a certain wattage, then there's a maximum temperature, ambient temperature, or board temperature in some cases, that you can use the product at. So you can see that if you're going to use the 8-lead SOIC package and run the product at 1 watt, then the maximum ambient temperature is 50 degrees C. Now, you look at the chart and you go, well, I could run it at 2 watts as long as I keep it at minus 50 C. But we do show, these temperature derating curves, so you can figure out where to set the product and how to apply cooling to keep the product in the right range. Now, this is for a two-junction max of 150 C, but 125, then these curves would move over. So then another factor in terms of things that can cause the product to fail are the ESD, or electrostatic discharge. And this is the thing that happens when you walk across a wool rug in the wintertime and and zap the dog just for fun. And it used to be that you had to be very careful with any kind of electronics that you might use to prevent this from happening, because even a little bit of electrostatic discharge could cause failure modes, and it was a common failure mode in electronics at one time. Not so much now, because the products we design and system designers, we're putting much better protection. We've got ESD diodes on the front ends of the parts that really keep these things much safer than they used to be. But you need to be careful during prototyping and testing, because you're going to be, handling the products and and the chips, and you don't have protective measures in place. So use ground straps and whatnot. Now again, ESD failure is not necessarily catastrophic. The product could still work for a while. It might not work the same. So that it's important to use all the cautions, during use of the part. So another thing that has come up, which we don't typically put on the data sheet because it can change if we change the packaging, is package moisture absorption. And what happens is these very small packages, which are plastic or epoxy, have a lead frame that goes from the center of the package to connect to the chip, and then outside so you can connect to your board. But even though these things are made very, very carefully, there can be small voids that can absorb water under the leads if they're not stored carefully. And that water, during the reflow cycle at 300 C, will boil and it'll crack the package. Now, you find it right away, but it sure is a pain to have it happen during assembly. And what happens in our case is, what we do is we bake the products out so that when we and put them in a dry pack material, or a shipping material bag, dry bag, so that they're okay when they're shipped and they're usable. And then of course, you have to take them out of the bag to run them through assembly, and there's a time period, and that's determined by the moisture, the moisture level rating for the product. And then you need to, everything that's been opened and hasn't been used needs to be put back into the dry pack. Once the device has been assembled and has gone through the solder reflow cycle, then it's going to be okay, because you're not going to have it up at 300 degrees C again after that. And the moisture absorption of the product to the point where it would compromise performance is at a very, very low level. So that usually doesn't happen. And in many cases, you will coat the board and whatnot, so that if you can find the moisture sensitivity level (MSL), it's not, I say, normally shown in the data sheet. It is found in the material declarations. The information is readily available. It's also on all of the packaging material, so that you get the thing in the dry pack and it says this is your MSL rating, and manufacturing people, assembly people know how to deal with that. So now let's get to the fun part, what you do with the product. That's all the details. Let's look at how you go about using it. The theory of operation is the next section. It will show how the part works, what it does. It may be necessary in selecting a complex product or for a complex system, and you go into that and you say, nah, that's not quite the way I need to have it work, such as an A to D converter that has a very high sampling rate, but the nature of the design is that from the input to the output is takes several microseconds, even though it has a very high speed. Maybe you can't use that. And it certainly helps you in setting up the product. Sometimes you can look at the theory of how it is designed or how it works, and you go, oh, I could do this with this thing, and make this kind of a system work, and can give you some good ideas. So this is, again, the owner's manual section. We then go to the description of all of the various functions of the product and how you get those functions to work. Each function is described. It shows you how to set up the power supplies, interface of the product. There will be software support when that applies. So everything you need to know about some assembly required is in this section. So of course we'll get into a block diagram or a simplified schematic. Here we show a simplified schematic for an FET input amplifier, and we don't show everything. We don't show the resistor values, and part of it is competitive, if you will, but then it also would get to be pretty involved if we showed everything that was on the schematic. But it can show you how the input and output stages work and what it's going to mean to you in terms of applying signals to the product. For a more complex product, we get away from the schematic because there could be thousands of circuit elements in it, and it would be more than would fit onto the data sheet. But we will show the block diagram, and then that shows you the functions of how everything works internal into the part. Again, may give you some ideas for how it will work in your application, or ways that you'll need to accommodate how the part works to make sure it's going to do your job. So we show a pin-out diagram, which is you need that. What happens on each one of the pins? We'll show different grounding, particularly an analog ground, a digital ground, and make sure that analog signals are grounded that way and digital grounded separately. Normally you'll connect analog and digital grounds at some other common point, often at the power supplies, so that digital noise does not corrupt your analog signals. We'll often have pins that are called NC, which means no connect. In some cases, an NC pin, it means what we have is a part which has 25 operating pins, and it's a 28-pin package. So there's three pins that are NC not connected. We've also gone to a new standard called DNC, do not connect, and that means that it was a pin that we used for some sort of testing function, but you should not be using it because it could disturb the performance of the product. In most cases, for the NC pins, if they're not specifically called DNC, then it's good to just ground them, and that will keep any sort of pickup noise from getting into the package. You'll also find that there's an exposed thermal pad on many products that are used at high power, and make sure you see where that pad should be connected electrically. Most of them should be connected to ground. Some of them will be connected to a power supply, and you want to connect that, solder that to a large copper pad to get very good thermal results. So this would show the description of each one of the pins and exactly what it does. And these are not all data sheets go into quite this much detail, but it gives you a pretty good idea of how to make sure that product's going to work out right. We then show typical applications. How the product is connected up. The input signals, how you route the output signals, and so on. And there will be many of these on most data sheets. And one thing to note is that we test all of these. We build all of the typical applications, and we'll test them on the bench to make sure they function the way they say they do, the way we say they do. We do not do full industrial testing on them. In other words, we don't test these over temperature. We don't test them under various environmental conditions or with values of resistors that might not, that would be out of tolerance or whatnot. So that, and occasionally we'll get a question that, well, we set it up like this and it didn't work quite the same. Well, we don't go through that kind of effort. We do build them all. It's going to be, if you want to use the applications, you still need to go through your full testing regime to make sure it's going to work for you in production. And we'll have quite a few of these to give you a lot of ideas. So some of our data sheets are very, very long. They can run to 100 pages pretty easily, and you can have an additional software hardware manual that could be 1,000 pages. And I used to write data sheets, but it was a long time ago. I think about the longest thing I ever wrote was around 24 pages. So I'm glad I'm not doing that today. But in order to find information in the data sheet, unlike the paper data sheet, if you bring these up in the Adobe Reader, you've got search functions available to you that can help you find technical terms or aspects of performance that are of interest to you. And that makes it an awful lot easier. You can bookmark. We will often bookmark the table of contents, so you can walk down through the table of contents, click on that, and it'll take you to that page. You can also go to a thumbnail function, which then shows you small versions of each of the pages that give you a better picture of what's in the data sheet, and you can quickly get down to the type of thing that you're interested in. So we also provide a revision history of the data sheets, not provided by everyone. And what we'll say, as you can see here, that when we change from, say, the last one here, Rev E to Rev F of the data sheet, that there are changes to certain figures. And then we started doing that because we would put up a new rev of the data sheet, and the customer would say, what changed? And so now you can go find out, and if it's really important, we do have old versions of these, so you can say, change from what to what. Now, if we change a specification, we will send out a product change notice to everyone who buys the product, so that if you're in production, we'll send out a PCN and say, this spec changed. But if it's something that just changed in the wording, the change in an application, or perhaps an addition, we don't send a PCN out for that. Package drawings are at the at the end of the data sheets and give you all of the details and mechanical limits of all the packages used for that given product. Now, in many cases, what you really want is an outline drawing that you can use and a pinout that you can use in your CAD package. And what we provide then on the product page of the product is that you can click on a thing called Symbols and Footprints, and then that has both the pinout layouts as well as a block diagram for the product with all the pins, so that you can do schematic capture as well as layout. And this is these symbols and footprints are available in a wide variety of layout packages, so it really makes your life a lot easier when you're trying to build this material up. The other thing, which is on essentially the last page of the data sheet, is the ordering guide. This is a list of all of the models that are available for purchase on that product. It shows the temp range, package. In some cases, if there's a difference in specs between the models, that will also be included in the ordering guide. The data sheets are you know, when we make changes in the ordering guide, it will show up right away on the website product page, and it'll show up at the bottom. It might take us a few weeks to update the data sheet, but you know, if you want to see what the latest is, you often want to look on the product page for that. We also have evaluation boards for essentially all of our products. For simple evaluation boards, like say for op amps, there will be a description of that on the data sheet itself. For more complex ones, there will be a separate user guide. And we have Gerber files, layouts, bill of materials on the user guides for all these evaluation boards. And we really recommend you get a hold of these boards. Makes your life a lot easier, and also make sure when you're evaluating the product that it's going to work the way we say it does. So what's not in a data sheet? First of all, the pricing is not in a data sheet, and you know, pricing changes worldwide, and it also changes in terms of the number of parts that you might want to buy, and it changes over time. So we don't put that in there. Whether or not there's any current inventory of the product, that's of course a dynamic situation. Moisture sensitivity level, I talked about where you can find that. Also on our website, the quality and reliability ratings for the product are available, and sometimes that changes over time. We don't keep that on the data sheet. The eval board, as I mentioned, is in a separate user guide, and there are often updates in terms of tech support that you can find out on our engineer zone, which is quite easy to find. You enter the part number, and often there are discussions on there about the product performance and how other people have used the product, and you know, how they've made it work, and maybe some things they've run into. So other useful information about data sheets is that sometimes there's spare pages at the end, particularly on the older data sheets, because we printed them on paper, and you have to print 4 pages at a time, and sometimes we would not have exactly 4 pages increments in the material we created, so there might be some blanks. Usually it'll say that. We do have old revs, but you know, we don't like those to be readily available, because then you could get the wrong information. There's software often for particularly converter type products, and you can get that as downloads. Other sources of information, our website, there's the product page, which will show similar products, the pricing of the product. You can find out package details, application notes about how to use the product. Our circuits from the lab are more involved applications than typically you find on a data sheet, and very good, and are set up to show the circuits in real complex systems. The models, in other words, the simulation models for the product that are either online or downloadable into packages like Spice, quality and reliability, and then the engineer zone for tech support. So a lot of extra information that you can find online. And now what we've done, a new addition to our data sheets, is we've set this all up in the data sheet as a set of quick links, so that it's typically in the first 2 or 3 pages of the data sheet, and you can, if you download it as a PDF, these links will connect to our website and get that additional information. So it's much easier for you to find that information now to to get the what you need to get the product to work. So that's a pretty good thing. So that's of course, this is mostly on our newer products, or whenever we update the data sheet on an older one, we're adding this, but it's rolling out. So makes it a lot easier for you to get to the resources you need. So that concludes our discussion of what to find on a data sheet and how to get the information you need. Thanks very much.
Thank you, David. Now let's jump right into our Q&A. Where can I get the package layout to use in my CAD software?
This is again a pretty useful thing that you can get on the product web page, and it you want to look for the what's called symbols and footprints, and you click on that, and then you'll go in and enter the type of layout package that you have, and that will then download to your system. You can also get sort of a bulk download of many types of products at once.
Thank you. The next question is, can I run the product at the absolute max rating? What will happen if I do?
We set the absolute max ratings as the absolute max. In other words, we don't put a guard band on our absolute max ratings. That really is the limit. So that and we set those limits by by testing, so that it's the number that we say it is. Whereas when you're running the product and we say something's like 18 volts, if something's off in your system and it's really 18.5, you have now compromised the product. So we recommend that you stay a good amount away from the absolute max ratings. And in many new products, we're putting in a thing called max operating conditions, which is a number you can operate at safely.
Okay, that's great advice. Thank you. Our next question is, where can I find the brand that will be on the package?
The branding is of the part will vary according to the package type, and that changes with package type, also with sometimes with the people who are doing the assembly for us. But in most cases, you will find the model number of the product without the part that says the real type. So it would be the full model number that you see in the ordering guide will be branded on the package. And then under that will be something that relates to a date code for the package, which could be necessary in some cases, but it will show the part number. For very, very small packages, we will have a code that relates to an internal system of ours to that part number. But if there is a code, it will show on the data sheet in the ordering guide as being the branding code, and then you can tell what it is. In a lot of cases, our branding has gotten to be almost microscopic because we can do it with lasers, and you might have to get out a magnifying glass to to actually see the brand. But it is on the ordering guide.
Okay. Thank you. That's a great explanation. Okay, we have time for one more question. It is, how are the typical performance curves generated? Are they tested?
What we do with the typical performance curves is that we'll take hundreds of parts from different production lots, so we get a spread, and test engineers who will set up in the operating conditions that we show on the data sheet, and then we'll test all these products, record the results, and then generate a typical number from that. These specs are also tested on a periodic basis by our quality department to be sure that we haven't had any changes.
Thank you, David. This is a great presentation, and we really appreciate you sharing your insight and expertise. Folks, this concludes today's presentation. On behalf of Electronic Design, I'd like to thank Analog Devices and Mouser for sponsoring today's event, and of course, all of you for joining. Have a great remainder of your day.